Hey guys, today we're going to look at how to find the derivatives of inverse functions. And in order to do that, we're going to go ahead and review what an inverse function is. Now, as a reminder, an inverse function is when you have the x and the y values of a function switch for the inverse. So what was the x for the function is the y of the inverse, and what was the y of the function is the x of the inverse. Additionally, the actual definition of an inverse function is when you have your function and the inverse, and if you find their compositions, you get x. So as well, if you do f of g of x, you get x, and as well, if you do g of f of x, you also get x. That would mean that f and g would be inverses. Now this is the notation for an inverse. You have f, and then this little exponent here of -1 indicates that it is the inverse of x. Another property of inverse functions is that if you were to have your function and the inverse, they would be a reflection along the line y is equal to x. And you can see here what I was talking about. The x of the function is the y of the inverse, and the y of the function is the x of the inverse, and etc. So here, just to reiterate, when two functions are inverses, if f of -1 is equal to 2, then f inverse of 2 would equal to -1. And that's because these two here just switch. So we're going to use this chart here of x values, f of x values, and g of x values to see if we can answer some of these questions. If I was trying to fill in this chart for the inverse of f, then that means that the y values of f of x are now the x values. So here in this column, I would put 2, -1, and 4. So I took the y's of f and they became the x's, just because that's what inverses do. Then that means that the inverse values of f are the x values of the function. So here would be 3, 1, and -1. So like I said, they switch places. Now over here, I would do the same thing for the inverse of g. So what was the function values for g become the x values of the inverse, and what was the x values become the y values. And now we're going to see if we can answer these questions. Find the value of f of g inverse of 0. So I have my chart already. So I can just go ahead and use my chart for the inverse to find these values. So the inverse of g of 0 would be 1. So this is f of 1. And then I would come back here, f of 1 is equal to -1. Over here, find the value of f inverse of f of -1. F of -1 is 4. So we're looking for f inverse of 4. This is my chart for the inverse. When x is 4, the y of the inverse is -1. Over here, we have find the value of f inverse of g inverse of -1. So I'm going to go here to my chart for the inverse. So this is when x is -1, the inverse is 3. So f inverse of 3. And I come here, and the f inverse of 3 is not on my chart. So we would just leave it like this. Then we're going to find the value of g inverse of f inverse of 4. So f inverse of 4 is -1. So we're looking for the g inverse of -1, which is equal to 3. Now, how do we find the derivative of these inverse values? So remember what I said earlier, that f of f inverse of x is equal to x. The composition of f and its inverse will always equal to x. And so what I've done here is that in order to make notation a little less confusing, I replaced f inverse with g of x. Now the whole point here is to find the derivative of the inverse, which would mean to find g prime of x. So what I'm going to have to do here is differentiate both sides so that I could then maybe isolate g prime. This right here, this would be considered chain rule. So I would do f prime of g of x times g prime of x is equal to 1. And since I'm trying to solve for g prime, what I would do is divide by f inverse of g of x, f prime of g of x. So g prime of x is equal to 1 over f prime of g of x. And that is how you find the derivative of an inverse function. Now, many people use that a is equal to g of x. So you'll see sometimes this notation, g prime of x would equal to 1 over f prime of a. Now, let's go ahead and work on some sample problems so that you can understand exactly this process. I put some steps here for you to find f prime of the inverse of b for a point AB on f of x. First, you're going to find f prime of x. If you are only given b, which is the x value, you have to figure out what the y value would be because the y value is the x value of the inverse. So you would set b equal to f of x in order to find a. Then you would find f prime of a, and we would write the answer in the correct format. The derivative of the inverse is equal to 1 over f prime of a. So let's try this out. Here we're given the function f of x is equal to 4x minus 3, and f prime of 2 is equal to 4. And we want to find the value of f inverse of 5. Now remember that this is the y value of the function. So in order to find the x value, we're going to go ahead and plug this in to my function here. So 4x minus 3 is going to equal to 5. And now I'm going to solve for x. So I'm going to add the 3 over. I get 4x is equal to 8, and then divide by 4. So x is equal to 2. So that means that I am looking for f prime of 2, which is given to me here. F prime of 2 is equal to 4. So what does this mean? This is that f inverse of 5 prime is going to equal to 1 over f prime of 2, which is equal to 1 over 4. Now I know that this process could seem confusing, so let me just kind of re-explain it a little bit. Okay, let's look at this problem a second. We have, suppose that f of x is equal to 3x squared minus 2, and we're looking for the value of f inverse of 10 prime. So we're looking for the derivative of the inverse when x is equal to 10. But the x value of the inverse is actually the y value of the function. So this right here represents the y of f of x. So in order for me to find the inverse, remember that in order for me to find the derivative of the inverse, please remember that the derivative of the inverse is equal to 1 over f prime of an x. We need the x value. So in order to find the x value, we take the y value and we plug it into the function as the y. So 10 equals to 3x squared minus 2. And then we have to solve for x in order to find the x value that we're looking for the derivative. So here I would add the 2, so 12 is equal to 3x squared, and then divide the 3, x squared is equal to 4, and then we would square root, and we get x is equal to 2. So that means that f inverse of 10 prime is equal to 1 over f prime of 2. So now what I have to do is I have to find f prime of x, which is equal to 6x, and f prime of 2 is equal to 12. Therefore, f inverse of 10 prime is equal to 1 over 12. So here I put as step one is to find the derivative of the function. You don't have to do that as step one. You can do that later after you find the x value, but essentially you do have to do these two things, whether the order does not matter. So b, remember, represents the y value of the inverse. So in order to find the x value that you need, you set the function equal to that y value in order to solve for a, which represents the x value. Okay, let's look at this one, which is a calculator question. What is the value of f inverse of x when x is equal to 3? So remember that this x value of the inverse is the y value of f of x. So what I need is the x value of f of x, so that way I can set f inverse of x prime would equal to 1 over f prime of a. So what I'm going to do now is I'm going to take my calculator and I am going to plug in this function. So 1 over 4, I'm going to put this in parentheses to indicate that it's just the one, like just the one that's being divided by 4. X cubed plus x minus 1. Now the thing is that if I were to find, the calculator doesn't know how to find an x value for a particular y value. So what I'm going to have to do is I'm going to have to subtract the 3 to make it equal to 0. So I'm going to subtract 3. So I guess you can also put minus 4, but regardless, it doesn't matter. So I'm going to go ahead and graph. Now, in order to figure out what the x value is, what I'm looking for now, since I set my equation equal to 0, I'm looking for the x-intercept, which is the 0. So I'm going to go to second calc, and I'm going to click on option 2 for 0. It's going to ask me for the left bound and the right bound, and I get that x is equal to 2. And remember the x value of the function, that is my a. So a equals 2. So I'm going to now find the derivative. So f prime of x is going to equal to 3 over 4 x squared plus 1. And I can also plug in the value. So f prime of 2 is going to equal to 3 over 4 times 2 squared, so 4, plus 1. These 4's would cancel, and I'm left with 3 plus 1, which is 4. So this means, right, remember it's this, that f inverse of 3 prime is going to equal to 1 over 4. So sorry, I got ahead of myself. This is all this. So this first part A was just to find the inverse value when x is 3, which was the 2, and then the value of f inverse prime of x when x is equal to 3 is the 1 over 4. So these are the two different kinds of notation that you can see. Sometimes it'll say f inverse prime of x, or sometimes it'll say f inverse of 3 and then in bracket prime, and both are correct notations. Now let's go ahead and see if we can use some charts here. First, we're going to find the value of f inverse of 3 prime. Now this means that I first need to figure out what is the inverse value. So here, remember that this is the y value of my function. So I'm going to go to the y values of f, which is 3, and I look for the x, which is 1. So this means that f inverse of 3 prime is going to equal to 1 over f prime of 1. And so when I look here, I go to f prime, which is 2. So my answer would be 1 over 2. Let's try this again with g inverse of negative 2 prime. So first I need g inverse of negative 2. So I'm going to go to my function for g. I go to negative 2, and my x value is 1. So the derivative, g inverse of negative 2 prime is going to equal to 1 over g prime of 1. So I come here, I look for g prime of 1, which is 1. So I get 1 over 1, so just 1. Next, we're going to estimate the value of g prime of negative 1. Based on this value, what conclusion can be made about the graph of g when x is equal to negative 1, and explain. So this has nothing to do with inverses, but I'm just bringing you back to some of the older material so that we can just make sure it stays fresh. So to estimate the value of g prime of negative 1, remember that we have to use a point to the left and a point to the right. Negative 1 is between 0 and negative 2. So that means that I'm going to find g of 0 minus g of negative 2 over 0 minus negative 2, so plus 2. G of 0 is negative 3, and g of negative 2 is 2 over 2. And I get negative 5 over 2. Based on this value, what conclusion can be made? We would say that g of x is decreasing at x is equal to negative 1 because g prime of negative 1 is less than 0. Now we're going to estimate the value of g double prime of negative 1. Based on this value, what conclusion can be made about the graph of g prime when x is negative 1? So there is such a thing as higher order derivatives, and we have the first derivative and the second derivative. So the derivative of a function tells you whether it's increasing or decreasing. So if I'm finding the second derivative and I want to know about the first derivative, it's the same relationship. So the second derivative tells me is the first derivative is increasing or decreasing. So I'm going to go ahead, in order to estimate g double prime of negative 1, that would mean that I am using now the first derivative. So we need to, again, choose those values on either side, which is still 0 and negative 2. So I'm looking for g prime of 0 minus g prime of negative 2 over 0 minus negative 2, so plus 2. G prime of 0 is 2, and g prime of negative 2 is 3. And we end up getting negative 1 over 2. And what does this mean? Again, same relationship. So g prime of x is decreasing when x is equal to negative 1 because g double prime of negative 1 is less than 0. Now let's look at one more question. We're going to look at this sample multiple choice question. If f of x is equal to g inverse of x and f of 2 is equal to 1, what is the value of f prime of 2? So we have to kind of break this down. We have a lot of information here to work with, but if we're looking for f prime of 2, that means that I am looking for, I remember that f is equal to the inverse. I am looking for g inverse of 2 prime. So this means that I need to figure out what the x value for g of x would be. Now, since I'm looking for that x value, we are told here that f of 2 is equal to 1. So this means that g inverse of 2 is equal to 1. So this is the y value of g of x, and this is the x value of g of x. So what I'm looking for here is 1 over g prime of 1. I have g of x is given to me in the question, so now I just need to find g prime of x, which is equal to 3x squared plus 1. So now I can plug in the 1, and I get 3 times 1 squared, so 3 plus 1, which is 4. Therefore, we get that 1 over g prime of 1 is 1 over 4. So B. And that's derivatives of inverse functions.